kids! Welcome to a new module! Hip hip hooray! Isn't it fun to start something brand new and a little bit different than what we've been doing? Module 6 is all about graphing and using it for data and to show the results of different things, and it's really fun. I love it. It's like finally we got here. So we have special names and words that we're going to use, and one of them is a coordinate system. Now, you look at this and you go, ooh, coordinate system, that's a big word, it's scary. No, it's really not. If you coordinate plans with friends, you say, well, let's all meet up on Saturday. So coordinating is nothing more than agreeing on something and getting together. So constructing is building a organized and coordinated system that is regular, but we're using lines to do it, okay? Lines, they're so great. This is just kind of warm up, don't worry about that. Here is where the lines really begin. So usually in class, I will say, okay, get a ruler or just draw the line. It doesn't have to be straight. It's not about the straightness. It's about the interim between each different number. And so what we're really doing in lesson 1 is learning that a number line, first of all, you can count by anything. Your number line can go in any direction, and you have to figure out what they're counting by in order to put points in the right places, okay? So as you can see, these have like different random things, and so this will be like, point A, point B. But first of all, what you want to notice is that 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, this number line is counting by ones. Okay, now on this one, it's always helpful if you can find the 0. Now, if the number line doesn't have a 0, and it may not, you have to look at the fractional units. And so if you see these tick marks and you go, and you don't have any of this, and all you have is 1, then you would say, 1, 2, 3, 4, 5. 5 tick marks makes 1. That means I'm counting by fifths. And then you can go ahead and label 1/5, 2/5, 3/5, 4/5, 5/5, and so on. For something like this next one, okay, instead of fifths, if you've got, all these different tick marks, and then it's like every other one is a whole number, then you know you're counting by halves. So you really just have to look and pay attention to what they're counting by. Now here are some more notes. Write this down. Everything that I show you on these videos, you should write down. Number lines. Stay focused. So first of all, somewhere you're going to have a 0. You have to figure out where the 0 is. Is it going to be at the left? Is it going to be at the right? The top? The bottom? I don't know. Now, lines continue forever in both directions. And you can count by any unit, not just fifths or thirds. You could do ones. You could count by 5s, 10s, 100, 1,000. Okay, when you talk about government expenditure, okay, you can count by the millions. So number lines can be any unit. When you draw the number line, the tick marks must be equally distanced. Okay, that's really important. You can't just have like the little tick marks like one here, one here, one here, one here, and then one here. Like that doesn't work. They have to be equally distanced. Some lines go up, some go down, some go left, right. Another important vocabulary word, 0, is going to be called the origin. The origin is where things begin, okay? And another important vocabulary term is we're going to use this coordinate pair. Sometimes you'll see it written as ordered pair. And we're going to be using X and Y all the time. There's going to be an X coordinate and a Y coordinate. Now remember, in your alphabet, X always comes first before Y. And when you write your coordinate pair, it's going to be X first, then Y. Okay, and I always like to say that on the coordinate grid, you'll see it soon that you can crawl before you climb or walk before you climb, and so you'll see when we get to the grid. Now if I have 0, 0, this is going to be the origin because they're both at 0. 0 for X, 0 for Y, and then you would go out from there, up and out from there. Don't worry if you don't get it, just write it all down. Okay, now here's some examples of number lines. Try to use the origin as the reference point and figure out which way are you going, okay? Here's an example of a number line that has 0 at the right and it's going to the left. Notice all the equally distanced little marks, okay? This one has 0 at the bottom and it's going up. Notice the equally distanced marks bigger than these. Notice this one, it has 0 at the left and it goes off to the right. And again, we've got little halves and it's all pretty tight. Okay, another thing that you can know that they have kids do in this lesson is take a piece of binder paper and put the red at the bottom and have these nice parallel lines, noticing, facing upwards. If you have a random piece of paper laying around like I do, because teachers have this paper everywhere, what you can do is you can make a ruler or a marker or a line to count by any distance. Notice that as I turn my paper up, you can kind of see that the distance between each potential tick mark could change. So if you don't know what I'm talking about, I'll just lay this down so you can see that off to the left, this could be the 0, and then I could have 1, 2, 3, 4, 5. And I don't necessarily have to count by ones. I could count by a third or a fourth or whatever. Okay, so this can be a counting tool right there. But I can also take this same paper and change the length in between so that if I have this is my 0 and this is my 1, 2, 3, 4. Okay, now all these lines, or what could be tick marks, okay, they can be different distances. And if you compare these two, you don't really need a ruler to make a straight edge that you can count by with regular tick marks, okay? So use any little piece of scratch paper and you can create different sized counting objects. So that's what they mean if they say, get your little paper out with the tick marks and change it. Okay, digging down. Now, what does that have to do with the book? Not much. Fortunately, this lesson goes pretty quickly. But they may say, oh, take your special paper. Okay, so let's jump in. Each shape was placed at a point on the number line. Oh, and then this is a cursive S. They're going to throw in these little symbols. Don't think that it's anything special. They're just calling it, that's the name. It could be like Francis or Bob, but it's line S. Give the coordinate of each point below. So this number line has 0 here, 1, 2, 3. Every 3 marks, we have a whole number. So you know that each one you could label with thirds. And this could be 1 1/3 and 1 2/3, etc. And 2 1/3 and 2 2/3. But all we really need to know are the locations of these shapes on the number line. So easy peasy and fun. So this one is at 3. Okay, starting off easy. Star, we already marked it at 2/3. Circle, we already labeled it 2 1/3. And the square down here, we know we're counting by thirds. This would be 4 1/3, 4 2/3. Okay, there's the top. Now in the middle, plot the points on the number lines. Okay, we have a 0. We have tick, tick, 3. Easy enough. There you go. Plot point A so that its distance, this is where they start to throw you, the language. Plot point A so that its distance, A's distance, from the origin is 2. From is a really important preposition. Okay? The distance from the origin. 1, 2. The distance from the origin. So this is what's going to throw all the kids out there, this wording, okay? Let's continue and you'll see as it gets even more fun. Plot point R so that its distance from the origin is 5/2. Oh, well, what do you mean 5/2? Well, turn it into a mixed number if you must, but this number line is counting by halves, and we have improper fractions. So if you continue in this same format, 1/2, 2/2, 3/2, 4/2, 5/2, so that you have a pattern. What if you don't have halves? What if it changes and it says this is 1 and this is 2 and this is 3? Like, what would you do? Well, you'd have to convert this to a mixed number so that you could figure out where it falls. Anyhow, distance from the origin, which is 0, okay, is 5/2. So they're just saying, hey, label this, and they want to make sure you can count. So that's all you do there. But wait, there's more. But wait, it's blurry. Apparently, it's having trouble focusing. Okay, there we go. For C, plot point L so that its distance from the origin is 20. Now, look at what they gave you. They gave you 50, blank, blank, 35, blank, blank, blank. I have nothing to go on except these two. So you find the difference between what they give you, how many are in between, what are they counting by, fill in the blanks, and then you can solve it. So you might recognize that that's a difference of 15, and 15 divided by 3 is 5. So I can continue counting 35, 40, 45, 50. Now go backwards. 30, 25, 20. Now I never get to 0 on this one, and that's okay. I don't need to get to 0. I know that 0 is down this way somewhere. So plot L so that its distance from the origin is 20. Well, L is going to be here because its distance from the origin is 20. It's at 20. Okay, next one. Plot a point T so that its distance from the origin is, here we go, 2/3 more than that of S. So here's S, and I need 2/3 more than that away from the origin. So here's 5. This is what we know. Here's 4. Here's 4 1/3. Well, if this is 4 1/3, then this would be 4 2/3. Then what are all these things? Well, 1, 2, 3, 4, 5, 6. So there are 6 sixths in a whole here. So what are the thirds in relation to sixths? Okay, so the thirds would be, it would take 2 sixths. So just to kind of have a connection to the thirds, to the 6 tick marks. So now I need to plot this point T so that its distance from the origin, which is down here, is 2/3 more than S. So now I know that I have to hop 2 from S, and I would go 1, 2. And that would be 2/3 because 1/3 is 2 hops. So 1/3, 2/3. And put your point and put the letter T. Okay? And you could also take 2/3 and see how many sixths that is. And you can turn it into 4 sixths and go from here 1, 2, 3, 4. That is also a great way of doing it. But I'm just counting in thirds. So next, number line G, fancy G, is labeled from 0 to 6. Use the number line G to answer the questions. Note that 0 is on the right. So they do a pretty good job in this lesson of giving you all these crazy number lines. 0, 1, 2, 3, 4, 5, 6. How many in between? 1, 2, 3, 4. That means each one is a fourth. You could number the whole thing if you wanted to, or you can just wait until the task tells you to. Plot point A at 3/4. So 1/4, 2/4, 3/4, and A. Plot it. Label a point that lies at 4.5 as B. Now don't forget, you're going this way. So 1, 2, 3, 4. 4.5. 4.5 is here, not here. This is 3.5. This is 4.5. 4.5 is B. Label a point C whose distance from 0 is 5 more than that of A. Now A is way back here, so I need like this plus 5. Now if this is at 3/4, then every time I count 1, I'm going to be on the 3/4. So 1, 2, 3, 4, 5. And this is going to be point C. It's 5 more than A. Plot. Okay? And then, what is the coordinate of C? Remember, you're counting by fourths, so this could be 5 and 1/4, 5 and 2/4, 5 and 3/4, and labeled. Okay? Next one. Plot a point D whose distance from 0 is 1 1/4 less than that of B. Where's B? B is here. And I need to have a full 1 1/4. Okay, so if it's 1, 2, 3, 4, this is going to give us the 1 whole. And then I also need to take off a 4th. And this is going to be point D. And the coordinate of D is, remember to increase your counting as you go this way, by fourths, 3 1/4. Next, the distance of E from 0, okay, is going to be 1 3/4 more than that of D. Okay, 1 3/4 more. So you're going to go 1, 2, 3, 4. Whoop, there's my 1, and 3/4 more. 1, 2, 3. And that's going to be point E. E. And we don't have to write that down, but hooray, we labeled it there. Check, done. What is the coordinate of the point that lies halfway between A and D? So here's A. Here's D. So, gosh, how many tick marks are in between? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if 10 would be the full, then 5 is the half. 1, 2, 3, 4, 5. And so the coordinate of the point that lies halfway is 2, and I need to label that point F. Okay, so I have a lot of arrows hopping around on mine. You may also have those. It really is helpful to kind of keep track of where you're going. And those are the answers there. And here is the last little bit. Mrs. Fan asked her 5th grade class to create a number line. Lennox created the number line below. Parks said Lennox's number line is wrong because numbers should always increase from left to right. Who is correct? Well, I hope you know after doing our lesson for today that number lines can go in any direction. So Lennox is correct because, write this down, number lines can go in any direction. Okay, so you can basically have, all directions. Just identify where the origin is, and then all you need is one other number, one other tick mark to show which direction it's going. Last one, a pirate. Ahoy, matey. A pirate marked the palm tree on his treasure map and buried his treasure 30 feet away. Do you think he will be able to easily find his treasure when he returns? Why or why not? What might he do to make it easier to find? Look for the treasure 30 feet from this tree. Where do you want to start, kids? Where should we start digging? Should we go 30 feet this way? Should we go 30 feet this way? That's a lot of digging. I don't know. What do you think? Oh boy, what do we do? That's a lot of holes. Okay, so the problem here is that I only have 1 point. Okay, so the problem, 1 point does not coordinate. Okay, and so what we need is we need that coordinate pair. We need another reference point. And so once you have this grid, okay, if you have a grid and you say, okay, here's the tree, and it's 30 feet, you know, in a positive direction or in a negative direction or in a negative or in a positive. And so which way is it going to go? Give me something to compare against. And so what you're going to find when we do get into these, this is going to be your X and this is going to be your Y axis. And these coordinate lines are going to give you something to refer to. Okay? So another way he could use the tree as the origin, perhaps, and have 2 other points to check against. 2 other coordinate pairs to check against. Okay, so lots of options, A-G-A-I-N-S-T, there it is. So, or tree. Like, where do you want to put the tree? I don't know. Give some coordinates, and then you'll be able to find the treasure. I hope this has been helpful. That's all there is for lesson 1. So come back again because we're in the last module of the year. So exciting. See you on the next video. Bye.